is no way of actually proving the shape and geometry of molecules and ions. However, there is a theory that successfully predicts the molecular shape, which is the VSEPR theory, valence shell electron pair repulsion. The Lewis electron dot model is used as its 4 electrons and at the alternate corner. The electrons are paired at the central atoms as far as possible to reduce repulsion force. Angles between bonds and the surrounding atom is thus position assumed by the valence electron. To explain further about molecular shape, let us look around and answer molecules.
Hey, do you know about this molecular shape?
Yes, this is called a linear molecular shape. A linear molecular shape has a bond angle of 180 degrees and has at least one atom surrounding its central atom. The 180 degrees bond angle form is because of the repulsion between electrons pair. Molecules with this shape has 2 bonding pair electrons and 0 lone pair electrons. Bonding pair electrons are valence electrons pair that are shared with another atom, while lone pair electrons are pair of valence electrons that are not shared with another atom. Wait, do you even know what does valence electron means?
Duh, of course. Valence electrons are electrons that are located at the outer shell of the atom.
Back to our topic, the 2 bonding pair electrons in this shape repel each other and creates the 180-degree angle between the 2 surrounding atoms of a molecule. Note that the strength of electron pair repulsion in the lone pair repulsion is strongest, while the electron pair repulsion in the bonding pair repulsion is the weakest. Although this might sound confusing at first, I ensure that by giving an example, it would ease this out more and make this topic even more clearer. An example of linear molecular shape is beryllium dichloride. Beryllium dichloride has 2 chlorine atoms which surrounds the central beryllium atoms. Each chlorine shares an electron with its central beryllium atom, thus creating 2 single bonds between the beryllium atom and 2 chlorine atoms. These 2 bonding pair of electrons will then arrange themselves to be as far apart as possible, creating the 180-degree angle. Do keep in mind that molecules with double bond or triple bond are considered and treated exactly the same way with those with single bonds, as they are counted as one bonding pair when predicting the shape of a molecule. Some examples are carbon dioxide and hydrogen cyanide.
Honestly, I have no idea what you just said.
Are you serious?
No, I'm kidding, but thanks for explaining. Now I'm off to find more molecules.
What a relief. Alright then, all the best.
Hey, is that a tetrahedral molecule?
Yes, this molecule has a tetrahedral molecular shape. The tetrahedral molecular shape has 4 atoms surrounding a central atom and 109.5 degree angle between any 2 bonds. Tetrahedral molecular shape has 4 electron pairs, which are 4 bonding pairs and 0 lone pairs. This is because all the valence electrons are shared between the central atoms and surrounding atoms. For example, methane CH4 has tetrahedral molecular geometry. Methane consists of 1 carbon atom and 4 hydrogen atoms, and each hydrogen atom connected to the central carbon atom by single bonds. Therefore, the 4 bonding pairs of electrons will repel each other, creating 109.5 degree bond angle. And since methane's molecule does not have lone pairs of electrons, only the bonding pairs are used to determine the shape of molecule. In other words, the shape of molecule or ion is the same as the shape of electron pairs. Other examples of molecules with tetrahedral shape are silicon tetrachloride, ammonium ion, and sulfate ion.
Wow, I guess everything comes in different shapes. Even humans, just like molecules and ions. Anyways, thanks for the information.
Well, that's true. Good luck.
Oh, hello there. Have you seen any molecules or ion here?
Yes, this is an octahedral shaped molecule. An octahedral shaped molecule has a bond angle of 90 degrees. An octahedral molecular shape has 6 atoms surrounding the central atom. The electron pairs consist of 6 bonding pairs and 0 lone pairs. As you can see, the shape of this model may be the most complicated among all the other shapes, but it is actually really simple. An example of an octahedral molecular shape is sulfur hexafluoride, which consists of 1 central sulfur atom and 6 fluoride atoms. There are 12 electrons surrounding the central sulfur atom, 1 from each fluorine atom. This makes up the total of 6 electron pairs arranged in octahedral shape with 90-degree fluorine-sulfur-fluorine bond angle. Another example of an octahedral shaped molecule is molybdenum hexacarbonate.
Thank you for the information. I guess this ends my hunts for molecules and ions. In a nutshell, molecules and ions with more than 2 atoms have a very specific shape. The three-dimensional shape of the molecule is important because it affects the chemical properties and the physical properties of the molecule. The VSEPR theory helps scientists to better understand the shape of the molecules. Therefore, I hope everyone understands this video. Thank you for watching.
This is the end of our short documentary. Thank you!